Hello and welcome! You probably all know the book series Where's Waldo, where your task is to find this little guy somewhere hidden in the crowd. And the question of the day is, can we train a computer to find Waldo? And a little spoiler, yes we can. But what I actually want to show you is a new feature in the Unity game engine that allows you to create synthetic training data for computer vision systems. And I'm using Waldo just as an example. But let's start from the beginning. And before I go on, please consider subscribing to my channel. Computer vision is a part of AI, or more specific, of machine learning. And computer vision is about identifying objects in images. There are three basic levels of identifying objects in computer vision. There are some others, but we don't care about them. The most basic task is called image classification. And the task for the computer is to decide whether an object is in the image or not. Is this an elephant, yes or no? Or is this a cat or a dog? This level of computer vision doesn't help us really, because we already know that Waldo is in the image. The second level is called object recognition. And it's not only about deciding whether the object is in the image or not, but also to decide where it is. So the task for the computer is to draw a bounding box around the object. This would already do the trick for us, but we want to go one level deeper. And the third level is called image segmentation. And the task for the computer is to identify which pixel in the image belongs to the object and which don't. And this is the level we are aiming at. Unfortunately, there's a big difference between humans and computer when it comes to learning. We can show a picture of Waldo to any kid, and the kid will be able to identify Waldo somewhere in the crowd. That's all we need to do. And the kid would be even able to draw an outline around the parts of Waldo that belong to Waldo. Computers, on the other hand, are stupid. They require a lot of training data to be able to learn a task. We can't tell the computer simply to find Waldo like we do it with a kid. In machine learning, the computer learns by example. So we have to provide the computer with a lot of examples where humans have already solved the problem. What does it mean? We have to provide the computer with two things. First of all, the original image. And second, an image or a mask that identifies the pixels that belong to Waldo. So somebody has to create this mask to identify which pixels in the image belong to Waldo. And this is a very time-consuming task that is no fun. Especially if I would also extend the task not only to find Waldo, but maybe all the dogs and traffic signs and trees. So somebody would have to manually mark all the pixels that belong to the dogs, the trees and traffic signs and so on. And this is how it's actually done today. But this also limits the amount of training data that is available for computer vision systems. So here's the idea. What if it would be possible to automatically generate new training data? Not only the annotations, but the images themselves. And one option for this is by using the Unity game engine. And that's what I would like to show you now. But for copyright reasons, I can't use the original Waldo. So hope you don't mind that this is my Waldo I'm asking the computer to find.
So here we are in Unity. And first of all, I will show you what happens when I press the play button. This looks pretty weird, so let's pause it for a moment and see what's going on. So what you see is how I try to mimic the Waldo style with my limited artistic talent. Every frame, 100 characters are positioned and rotated randomly with different poses. And also the background and the trees are changing. But what you also see is this yellow box marked Waldo. So what Unity does for us is not only to draw the bounding box around Waldo, but also highlight all the pixels that belong to Waldo. So every frame, a new image with the corresponding annotation is generated. In the background, Unity stores the images on the file system. On the one hand side, all the original different files, and also the segmentation files that highlights which pixels belong to Waldo. So here's an example of an original image and the corresponding segmentation file. This functionality comes with a Unity perception package, which at the moment has an experimental status. But the setup is actually pretty easy. So the first thing you have to do is to assign the perception camera script to your main camera. And in here you have to assign the different labels you want to use, like the segmentation labeler or the bounding box and so on. Any game object you want to track in the images, you have to assign the labeling component and assign a corresponding label. And then you only have to set up two configuration files. First, you have to define all the labels you want to track in the images. And if you want to do segmentation, you have to choose a color for every game object. The perception package comes also with some functionality to position the game objects randomly, but I tried it and it's pretty cumbersome, so I decided to write my own script, which is much easier and I have much more control over it. Unity also offers a simulation package that allows you to run the image generation in the cloud. But I only required a couple minutes to generate 10,000 images, what was sufficient for my test. So I haven't tried this.
Now with these images, I'm able to train a neural net to perform the task. I'm not going into details because it's a standard task in machine learning and I wanted to focus on the image generation. I'm using the fastai library for training the neural net because this makes the task pretty easy.
So what you see here is a typical Jupyter notebook running the Python environment that's required by the fastai library. And training the model only requires really a few lines of code. So first of all, you need to load the data and then check whether the data has been successfully loaded. So you see two examples of images with a corresponding segmentation mask transparently laid over the image. Then you have to define the model, which is actually just a single line of code, and train the model for some time. And here's the result. On the left-hand side, you see the original image with the right segmentation, and on the right-hand side, you see the image with the prediction of the segmentation coming from our trained model. The important fact is that the computer hasn't seen the image before. So we can say that now my computer is able to identify Waldo in any image.
For sure, this is just a toy example, but I want to show you the core principle. Unity has released a demo where they recreated packages of everyday goods. And with these objects, they are able to create photorealistic images of supermarket trolleys to train a system that supports an automatic cash register. And although this approach is still in early stage, it's already clear for me that it will become a standard approach in computer vision in future. So, hope you enjoyed it and see you next time.